Hello, it's Dr. Daystorms, and I wanted to go over how to determine formal charges once you have a molecule drawn. Since most of you are wanting to go into medical school or something with a biomedical field, I thought we would pick a compound that is biologically relevant. For those who go on to biochemistry, you're going to hear a lot about this compound. It's called arginine. It is one of the 20 naturally occurring amino acids in your body. Plus, it also plays a really important role in nitrogen metabolism and the urea cycle. Okay, so I have arginine drawn out, and I'm using the annotated method where the carbons are each vertex, and you are to assume that each carbon, unless noted otherwise, has 4 bonds. Remember, this is how you assume that there are hydrogens to make up that number of 4 bonds. Okay, so let's just look at the areas that would be important to determine formal charges. We can eliminate all of these carbons that have 4 bonds to them. Okay? We can eliminate all hydrogens as well. So that narrows it down. So let's focus in on first the oxygens. I'm going to look at this oxygen first. We want to see how many electrons does it own by itself, and that's 4. 4 lone electrons plus 2 bonds it makes would be 6. Now, oxygen is located in the 6th column periodic table, so that means it has 6 valence electrons. So therefore, this oxygen is neutral. Now, let's go back and look at the second oxygen. Once again, this oxygen came in with 6 valence electrons, normally. However, it now has 1, 2, 3, 4, 5, 6 lone pair electrons, and it has an electron for making a bond there. Whoops. So therefore, this oxygen has a charge of -1. So many times what we'll do is we'll put a little negative sign next to that oxygen, and then whenever I draw this many times, since I can get kind of sloppy, as I like to put a circle around it. That way you can clearly tell that it's a negative charge. Now let's focus on one of the other molecules. Let's look at this nitrogen here. Nitrogen normally has 5 valence electrons. How many electrons are around this nitrogen? If you notice, it's making bonds to 3 hydrogens, and it has a bond to this carbon here. So therefore, it has 4 total bonds it's making, and it has no lone pair electrons. So there 5 minus 4 is equal to a +1. So I'm going to put a positive charge on that nitrogen, and once again I'm going to put a circle around it so that way it makes it really obvious. Okay, let's move on to this nitrogen down here. Once again, nitrogens usually have 5 valence electrons, but if you notice this one, it's only making 3 bonds. So many times, the way that this is drawn in organic chemistry and biochemistry is here. Let me erase this. Okay, the way that it's drawn, you have to assume that that nitrogen wants to, fulfill the octet. That means it has 2 lone pair electrons around it. So it's 5 minus 3 minus 2, so therefore that one is neutral. So now let's look at the nitrogen down here. This nitrogen, if we notice, is making 4 bonds. 1 bond, 2, 3, 4. Remember, it likes 5. But since it's got 4 bonds around it, and each bond has 2 electrons, that means it already has a full octet. However, so it has no lone pair electrons. However, it only owns 1 electron in each of those bonds, so it'd be 5 minus 4. So therefore, it's going to have a +1 charge. So I'll go ahead and I'll put a positive charge on that nitrogen. Finally, I have a little shortcut method for you. Remember, if a carbon is making 4 bonds, it's always going to be neutral. Okay, provided there are no lone pair electrons. And a hydrogen makes 1 bond. Let's look at this nitrogen here. That nitrogen, it's making a total of 3 bonds. 1 to the carbon here, and 2 to those hydrogens. So therefore, in order for it to have an octet, it's going to have lone pair electrons. So therefore, 5 minus 5 will be 0. An easy way to quickly do formal charges is if a nitrogen is making a total of 3 bonds, it's going to be neutral. Likewise, an oxygen, for example, this oxygen over here, that's making a total of 2 bonds to something, is going to be neutral as well. Just remember, every time you draw a structure of a chemical compound, you absolutely must put in the formal charges, or otherwise it is incorrect. I hope this helps. See you in class.